brief sort of test. First problem that you're going to see will not allow you to use a calculator. So let's see if we can solve it. The area between these two curves, first step, set them equal to each other and find out what we have as intersection points. So x squared minus 4x plus 3 will equal 0. This will factor. I'm going to bring it over here so I have room. X minus 3 and x minus 1 will equal 0. So my intersection points are at 1 and 3. That means that I'm going to have that the area equals the integral with the limits being 1 to 3 of, I need to do one of the functions minus the other, top minus the bottom. So which one is it to do top minus bottom? Well, if I plug in something in this interval, so 2 squared would be 4, 2 times 4 is 8, minus 3 is 5. So g of x is my bigger because when I plug in, I get 4 here, 5 here. So that means that I have to do g of x, 4x minus 3, then subtract the bottom one, f of x. And now I can evaluate this integral. So the integral of 4x is 2x squared. That becomes minus 3x, and this will become 1/3 x cubed. And this needs to be evaluated from 1 to 3. So this means I'm going to plug in 3, and I'm going to plug in 1. When I plug in 3, I get 2 times 3 squared, which is 9, so 18. Then I'm going to subtract a 9. Then I'm going to subtract another 9 here. So I get 18 minus 9 minus 9. So that reduces pretty easily to 0. Now for this one, when I plug in 1, that becomes 2 minus 3 and minus a third. So 2 minus 3 gives me negative 1, minus another third will give me a negative 4 over 3. So I need to do 0 minus negative 4 over 3, which gives me a final answer of 4/3. That is the area between those two curves. All right, now the next two, you'll have the calculator to try to help you, but you can do it without the exact same way. First step is to set them equal. X squared plus 5 equals 2x squared minus 2x minus 3. I'm going to make, bring over the thing to this side, so I'll have x squared. I'll have minus 2x still, and I'll have minus 8. So when I factor, 0 equals x minus 4 and x plus 2. That means I'll have x will equal negative 2 and positive 4. So again, that means that this will be my limits of integration from negative 2 to 4. A number in between, there's lots of options. The easiest one to check would be 0. When I plug in 0, I'm going to get 5 here, and I'm going to get negative 3 here. So f of x is my top. So x squared, I will have plus 5, and I need to subtract this entire thing. So minus 2x squared, that'll make it a plus 2x, and I'll make it a plus 3 when I do this. Now, I'd like to simplify this because it'll make things a lot easier. You could do the integral right now. I'd rather combine what I can. X squared, so I'm going to have a negative x squared. X's, I'll have a positive 2x, and I'm going to have a positive 8 for my units. Okay? Now, let's see if I take this integral. I'll do now negative 1/3 x cubed. I'll have a plus x squared, and I'll have a plus 8x. This will be evaluated from negative 2 to 4. So again, I'm going to plug in 4, and I'm going to plug in negative 2, just like we did before. When I plug in negative 4, or positive 4, I should say, I'm going to have 64 over 3. I'm going to have 16 here, and I'm going to have 32 here. So negative 64 over 3 plus 16 plus 32. What I do for the lower one, I'm going to end up with a positive 8 over 3. I'm going to have a positive 4, and I'm going to have a negative 16. So I'm going to add these up, use a calculator to help you. You're going to get, for this one, you will get 26 2/3. So that would be 80 over 3. And for this one, you should get a negative, this should be a negative 28 over 3 when you get that common denominator. When you're going to do now is you go back up here. You're going to say, well, this now equals 80 over 3 minus my negative 28 over 3. So that equals, that's 108 over 3, and actually reduces to a full number 36. Again, use your calculator to help you, especially with some of these fractions that can get a little intense. All right, for this one, same idea. X cubed minus x plus 5 must equal 3x plus 5. That means that x cubed, we're going to have a minus 4x must equal 0. My 5s will cancel out. Factor out an x, I'm left with x squared minus 4. So that means I have x minus 2, x plus 2 must equal 0. So that means that x equals 0, 2, and negative 2. So this is the tricky one that we've talked about before where we have multiple intersection points. So what we need to look at, we're going to have the integral from -2 to 0 of one of those, plus the integral now from 0 to +2. The question is, which is which? Well, when I plug in -1 here, I'm going to have -1 plus 1 plus 5. So this top one will become 5. Let's make that a different color. Make it 5, +5. When I plug in -1 here, I'm only going to have 2. So that means that my cubic is going to be on top for the first part. When I plug in +1 over here, it'll still be 5 over here, but now this will be 8, which means G will be on top. So what that means is, for these two equations, this first one should be F on top, so x cubed minus x plus 5, and then I'm going to subtract 3x and subtract 5 for the first one. That should be dx. And I need to add the second one, which is just flipped around. So 3x plus 5, now subtract x cubed. I would then need to add an x, now I need to subtract 5 dx. And I know I'm kind of running out of room on you over here. So what this means, if I can simplify this a bit, let me get these guys out of the way, down here somewhere for you. All right, what that means is, I can now rewrite this if I wanted to. I would try to simplify it best I could. It would be x cubed, we'd have a minus 4x, that's what I have for the first one. Then the other one is going to be, should be the other way around. It should be a minus x cubed and a plus 4x dx. And you should realize that these end up doing very similar things. What you're going to do, take the antiderivative, 1/4 x to the 4th minus 2x squared. That'll be evaluated from -2 to 0. And then I'm going to have to add here, it would be -1/4 x to the 4th plus 2x squared this time. And that's evaluated from 0 to +2. 0 to +2. When I plug in 0 here, I'm going to get 0. When I plug in 2, -2 I should say, I'm going to get 1/4, and then this will be plus 8. So 1/4 plus 8 over here. When I do for this one, plugging in 2 first, and then plugging in 0 on the bottom. Again, 0 on the bottom will give me 0. When I plug in 2 up top, x to the 4th will be a pretty big number. It would help if I did this one right. It should be 4 over here to give you 12. You get the same number over here. You should get a +12. -4 and 8, so that actually shouldn't be 12. It would help if I would do this right. That becomes a 4 there. +4, -8 would have made it -4. So there's finally, let's just start that part over again. How about we do that? When I plug in -2, gotta love it, guys. When you plug in -2, -2 to the 4th power is 16, divided by 4 is +4. I then subtract whatever I have here. -2 squared is 4 times -2, that gives you the 8. So that means I have -4 here. When I do this over here, it'll just be the opposite. It'll give you +4. So that means my two answers, 0 minus -4 is going to give you +4. 4 minus 0 is going to give you +4. Those are the two you add up, you get to 8. For this one, I'll tell you though, all you're going to have to do is get to that point right there. Show me that you can set up the integral properly. All right, let's get away from area under the curve, and we're going to go to slope fields. First question says, where do you have a horizontal tangent showing up for these? Well, a horizontal tangent means just a flat line, and that's looking to happen anytime you have x equals 0. I might just give you some sort of, tell me something about the graph, that's what it's going to be. Next, draw a particular solution through the point 0, -2. There's that point, and I'm just going to kind of sketch it. It looks like it's flattening out there, and then it kind of goes back down. So there's 0, 2, and whatever happens with it. The other point they want you to look at is 1, 3. So like right here. And this one's kind of weird, because right here, it looks like you're going to hit the line no matter what you do. Technically, you should go right in between them. It's tough to tell what happens. If you would just kind of follow the arrows the best you can, that's all we can ask for. Now, drawing the slope fields, definitely a difficult thing to do. First thing I would look at, though, is anytime that you have y equaling 0, you're dividing by 0, you're going to have a straight up and down vertical slope at that point. Let's start plugging in some numbers now, though. If I have y equaling 1, that means whatever x plus 3 is, that's my slope. So let's start way over here. When x equals -2, that means I have a slope of 1. When x equals -1, that means I have a slope now of 2, so it should get bigger, and then keep getting bigger, and then over here it should almost be going straight up. When I go to y equals -1, the exact same thing is happening, except now they're negative. So it should look more like something like this, getting steeper and steeper as you go along. All right? Now, for the third one, when we go to when y is +2, that means that whatever x plus 3 is, I need to now divide by 2. So 1 divided by 2 is 1/2. So not quite flat, but pretty flat. It should have been, I'm sorry, no, that is negative, so there you go. Or no, it should be positive. So, see, it happens. Let's rotate that a little bit, make it a little bit positive. Okay, it's going to start increasing because now I'm at, this would be 2/2, which is 1. This would now be 3/2, so a little bit more than 1. This would now be 2/2, so 2, or 4/2, I mean, sorry, and then like 5/2, so a little bit more. A little bit more each time. And same thing down here, except they'll all be negative. So kind of get them to look the same way as they do up there. The best you can, just being sloped opposite. Again, it's an approximation, nothing you can do to make it perfect. All right, same thing here. First, I'm going to say at the origin, we have a flat line with 0 plus 0 is 0. Anytime that we have one positive, one negative being the same thing, that's what we're going to have. Some other characteristics you can look for here. 1, 0, that'll be a +1, this will be +2. This will be a -1, this will be a -2. And if continue going, it should be +1, +2. This should be -1 and then -2. 1 minus 2, that should be -1. 2 minus 1, so that should be a +1. Over here, 1 plus 1, +2. 1 plus 2, +3. +4, +3. Over here, 1 plus -1 plus 2, so that should be a +1. -2 plus 1, -1. So you have a line of -1s and a line of +1s happening here. -1 and -1 is -2. This would be -3, and then -4. So again, approximate it best you can. Doesn't have to be perfect, just so I can tell that you know what you're doing. All right, now finding general solutions and particular solutions to these. All right, first step is always change this y prime and make it dy dx. dy dx equals x plus 2 over y cubed. From there, I want to get the y's on one side, dx on the other. So multiply both sides by dx and by y cubed. So y cubed dy equals x plus 2 times dx. From here, this is where you go and take an integral of both sides. The integral of y cubed is 1/4 y to the 4th. The integral of x plus 2 would be x squared, 1/2 x squared, I should say, plus 2x, and then plus c. Right there, that is a general solution, right there and then. You can stop right there. Now, in number 10, it gives you a multiple choice question to say which one represents a general solution. Well, they want to get c by itself, and it looks like they've gotten rid of all fractions. So let's see if we can do that. To get rid of all fractions, I would need to multiply this guy by 4, and then that means I would have to do this whole side by 4 as well. And see, that should already get rid of this fraction. So that means I would have y to the 4th would equal 2x squared plus 8x, and 4 times a constant, it's still a constant, so plus c. Now they want to get the c by itself, so that means y to the 4th minus 2x squared plus 8x would equal c. I'm sorry, not plus 8x, that would be a minus 8x when you bring it to the other side. So that would be the answer that you have, and that was letter B on your test. All right. Number 11, finding a particular solution this time. We start the same way. We have xy dy dx is equal to 4. I'm going to get the x over to the other side and bring dx over there with it. So we'll have y dy will equal 4 divided by x times dx. I will go and take the integral again of both sides. When I do that, I should get here 1/2 y squared will equal, this will be 4 times natural log of x plus c. From there, they want you to find a particular solution. So that all that really means is take these numbers and plug them in. 0 for x and 4 for y. When I do that, what do I get? Well, I should get 1/2 of y is 4. I want to square 4 will equal 4 times the natural log of 0 plus c. I need to solve for c here. 4 squared is 16, half of that is 8. The natural log of 0 is 1. So 4 times 1 is 4 plus c. That means c is equal to 4. That means my final answer will be exactly what I wrote over here. 1/2 y squared is equal to 4 times the natural log of x. Now instead of plus c, it'll be whatever my number is, plus 4. All right, last thing on this test is using Lhopitals rule for limits. Always check when you go first, when you plug in 0. So in this case, 0 and 0, that's I can use Lhopitals rule. So I will do, using Lhopitals rule, that's the limit. As x approaches 0, take the derivatives. 1 over e to the x. When I plug in 0, I should get 1, so I have 1 over 1, which is 1. For 13, when I do this one, I could go and try to do Lhopitals rule. What I'm going to notice even first, though, is that this is still just the limit as x approaches 3. I can factor out a 3 up top. I'd have 3 times x minus 3 over x minus 3. Those would cancel each other out, and all I'm left with is 3. I don't even need to plug anything in for that one. Okay, for number 4, what I'm going to do here is notice that if I plug in infinity, I'll get infinity and infinity. So I'm going to have to do some limits here and do some L'Hopital a few times. When I do L'Hopital, I'll get 4x cubed plus 2x on top and 3x squared minus 2 on the bottom. Still plugging in infinity, I still get the same thing, so let's do it again. It's still a limit. As x goes to infinity, I'll now have 12x squared plus 2. My denominator is now 6 times x. Oh, I'm going to have to do it one more time. So L'Hopital's rule, the limit as x approaches infinity now of 24x over 6. Well, now if I plug in infinity, I'm going to get infinity over a number, which is, in the end, still infinity. So infinity is my answer for number 14. 15, plugging infinity again, I get infinity over infinity. So, L'Hopital, the limit as x approaches infinity, derivative up top is 2e to the 2x. Derivative at the bottom would be 3x squared. Same idea, I'm still having the same issue here, so let's do the L'Hopital again. Limit as x approaches infinity. So now I'm going to have 4e to the 2x over 6x. Well, still infinity, so one more time. Infinity over infinity doesn't work as an indeterminate form. So one last time, 8e to the 2x over 6. Now when I plug in infinity, I get, well, funny enough, infinity over 6 again. So I get infinity as my answer. Remember, just for example, if it was something like 6 over infinity, the other way around, that means your answer would be 0. Just a side note, we don't have an example of that on here, so I just want to make sure we have that in our heads. All right, number 16 will be the trick question. There will be a trick question. If I plug in 0, I do have 0 on the bottom, but I have 1 up on the top. I don't have 0 over 0, so I don't need to use L'Hopital's rule. I can just say 1 divided by 0 is just infinity. Number 17, the limit as x approaches 0. Sine of 0 is 0, x is 0, so I do L'Hopital's rule. So it's going to now be the limit as x approaches 0. Derivative of sine is cosine. The bottom is now 1. Now if I plug in 0, cosine of 0 is 1. It would help if I wrote the problem down right. It was not x on the bottom, it was 3x. That means the derivative on the bottom would be 3. So I now have 1 over 3 as my limit. And the last one, if I plug in 1, I get 0 up top. Natural log of 1 is 0, so 0 on the bottom. L'Hopital's rule comes into effect. Limit as x approaches 1, it will be of now 2x over 1 over x. If I plug in now, I'll have 2 on the top, which is good. On the bottom, 1 over 1, which is 1. So my answer is just 2 for my limit. There you have it. Remember these indeterminate forms. Remember the area between the curves. And hopefully you should be in good shape.